After the Industrial Revolution, the widespread availability of sucrose and highly processed foods led to the caries rate skyrocketing. Bacteria entombed in the calculus on ancient texts document the ensuing transition in microbial communities. However, processed food nowadays are softer and cleaner, setting up a perfect storm for dental caries. Less chewing to cut the organic film, and fewer dietary abrasives to wear away the nooks and crannies in teeth where bacteria take refuge.
According to World Health Organization, oral disease pose a significant health burden for many countries and affect people throughout their lifetime, causing pain, discomfort, disfigurement, and even death.
Moreover, the severe periodontal disease proved to be related to many chronic and cardiovascular diseases, with almost 10% of global population affected with periodontal disease. The issue of oral disease has been one of the top problems that pose a threat to human beings.
The treatment for oral health conditions is expensive and usually not part of universal health coverage. Dental treatment averages 5% of total health expenditure in most high-income countries and 20% of out-of-pocket health expenditure. Oral disease disproportionately affect the poor and socially disadvantaged members of society.
There is a powerful and consistent association between socioeconomic status, such as income, occupation, educational level, and the prevalence and severity of oral diseases. This association exists from early childhood to older age and across population within high, middle, and low-income countries.
Most low and middle-income countries are unable to provide services to prevent and treat oral health conditions. However, most oral health conditions are largely preventable and can have treatment in their early stages.
This year, we NCTU Formosa decided to focus on periodontal problems. Our project is about tackling the issues by preventing the happening of periodontal disease. The solution we provide will solve the problem of oral health and reduce the risk of getting other conditions related to it. Synthetic biology is the best method for us to achieve our goal inexpensively and efficiently. We believe that by developing our project, we can make the world a better place. Not only humans, many animals, especially human-rearing pets, also face oral health problems due to drastic change in diets. Therefore, we decided to focus on our furry friends' oral health before applying our solution to human beings. By optimizing our design through this procedure, we can adjust our project to the optimal place. After deciding to focus on canine oral health first, we visited Hsinchu Animal Protection and Health Inspection Office. Due to the lack of oral medical resources, many dogs suffer from oral-related disease. After the visit to the animal shelter, the idea of making their life more comfortable becomes firmer. To ensure our project caters to the needs of the actual situation, we invite professors in the dentistry and veterinary medicine department to discuss the concept of the project. Throughout the discussion with Professor Chen-Han Li, we choose the antimicrobial peptide inhibiting the growth of P. gingivalis. In interviewing with Professor Liu Pingchen, she recommended adding our engineered bacteria into the dental bone, making dental medical treatment more straightforward and less intrusive. Besides, Professor Liu Pingchen instructs us it is difficult to calculate a suitable dental bone feeding frequency. Thus, we construct an efficiency optimization model for precise dental bone feeding. We develop a plan to prevent our furry friends from suffering from periodontal disease and severe systemic disease. Our solution is to create a brand new dental bone, dentist bone, which contains proteins and peptides to prevent plaque formation and repair the damaged gingiva and tooth tissue.
The RBS of coron sensing sequence needs to exceed 37 degrees to enable its mRNA to begin translation and initiate coron sensing regulation. In this way, we can ensure that our engineered bacteria can operate in a specific temperature range. When the logs are protein binds to the AHL produced by all bacteria, It can prompt the P-lox promoter to start transcription so that inhibition sequence can express when there are more bacteria. When a TAP protein expressed, the P-TAP promoter will inhibit to achieve the antagonistic effect of the inhibition sequence. LOL37 is an antimicrobial peptide from humans. It can inhibit the growth of bacteria efficiently. BMP2 is a protein that has been well researched and proved to have sufficient ability to repair damaged gingiva tissue. STATH is a new part we added to IgG. It is a protein that humans prevent the precipitation of calcium phosphate. Its property can reduce the risk of oculus for teeth soaked in supersaturated calcium and phosphorus saliva. Therefore, STATH is available for promoting the remineralization of tooth enamel and preventing cochlear formation.
To incorporate Coron sensing dental pathogen inhibition and dental restoration into E. coli, we first built up the gene constructs and expressed red and green fluorescence proteins to ensure the genes were successfully expressed and test their functions to prove that the proteins secreted by dentists worked. Finally, we designed an experiment to warrant the biosafety of dentists. We designed an experiment to measure the intensity of GFP. This experiment lasted for 24 hours, and we measured the data every hour.
This data indicates that dentists can gradually express GFP. In other words, the restoration sequence can also be expressed.
Then, we also designed an experiment to measure the intensity of RFP.
This data show that RFP can be gradually expressed by dentists. In other words, the inhibition sequence can also be expressed, and the regulation of 3 sequences can be successfully expressed.
After finishing the design of dentists, we wanted to know whether its inhibition ability could have a function. So we designed an experiment which used the inhibition zone to confirm that dentists can inhibit other bacteria. Furthermore, we can also compare the difference of inhibition zone diameter to know the strength of inhibition intensity.
There were 10 different materials added to LB plates. Plate A added hydrogen peroxide as the positive control group. We could see that plate A only grew bacteria near the edge. Plates B and C were E. coli BL21 with PSB1K3 and dentists respectively, with other factors unchanged. Plate B was the negative control, and our dentist had an inhibitory effect. Plates D and E were E. coli BL21 cell lysates with PSB1K3 and dentists respectively, with other factors unchanged. Plate D was the negative control, and the cell lysate of dentists had an inhibitory effect. According to the results of plate A to plate E, we can know whether it was a live dentist or a cell lysate, both of which had a function of inhibiting bacteria. We repeated the dentist inhibition functional test 3 times each. This bar graph indicates the 3 times average of inhibition zone diameters in different materials added to LB plates.
This result shows that dentists can secrete LL37 to inhibit other bacteria.
Carbon rods are processes to have small, low-volume pores that increase the surface area available for absorption. We expected that both STATH and calcium could absorb on the surface of carbon rods. In calcium ions supersaturated solution with dentists, STATH will bind onto the surface of the carbon rod, preventing the calcium ions from binding onto it. The results show that the surface of the carbon rod taken out of the dentist was matte compared with that in other solutions. We presume that the result was due to the protective layer on the surface formed by the STATH that would prevent the liquid from attachment. With STATH functioning, No particles were seen on the surface of the carbon rod under the microscope, and the surface remained clear. We suppose that was because this rod had been soaked in a solution, which would bring away the dust on its surface. Besides, the surface of it was even cleaner than the original carbon rod. Carbon rod soaked in calcium ion saturated solution with E. coli Bl21 with PET32A as one of our control groups. The results show that there are many particles on its surface, which might be composed of calcium crystals. To prove that dentists can be inhibited by gastric acid, we conducted an inhibition of growth of dentist test. Because the hydrochloric acid concentration of the animal's gastric acid ranged from 0.15 m to 0.05 m, we modulated hydrochloric acid from 0.3 m to 0.1 m with equal dentists, observing whether the dentists in different concentrations of hydrochloric acid would be inhibited.
To make sure our design could work smoothly, we construct a prediction model. The prediction model simulated and predicted the result of dentists.
First, we simulated the growth curve of E. coli and P. gingivalis in dogs' oral environments. This is the prediction of our model. We expected that the OD value of both P. gingivalis and dentist would decrease due to the inhibition effect of LL37. In order to verify our model, we did some experiments. We found that it was necessary to consider the dead E. coli because it influenced the OD value. The red line was the prediction growth curve of dead E. coli. The blue line was the E. coli which was still alive, and the black line was all the E. coli including living and dead, which was the prediction of OD value. It showed that the OD value of E. coli that are alive decreased, indicating that dentists did have an inhibition effect on bacteria.
Comparing the result to the growth of P. gingivalis, the final OD value decreased from 0.7 to 0.08, which showed that our dentists could effectively kill 88% of pathogenic bacteria in dogs' oral cavities.
Controlling the time interval between each feeding is essential. Neither feeding frequency too fast or too slow is harmful to canine health. Moreover, the oral environment in different dogs fit different conditions. Thus, striking the balance of controlling time intervals is a challenge issue.
We use reinforcement learning to predict the customized feeding intervals based on the amounts of P. gingivalis.
To achieve the goal, we use PyTorch to construct our reinforcement model and predict next feeding time.
Moreover, we also show that our reinforcement learning model improves dental bone utilization efficiency compared to regular feeding. To investigate if the RL model shows better efficiency, we make a comparison with fixed-time feeding. The following figure is the cumulative reward concerning time of RL model and fixed-time feeding. We could observe that as the episode goes, the optimization efficiency of the RL model is gradually greater.
To validate the efficiency optimization model usable in any environment, we use E. coli, hydrogen peroxide, and glucose to simulate P. gingivalis, feeding dental bones and eating foods. We modify the environment reaction function in order to meet requirements.
The figure shows that the prediction value is close to the experimental data, and the prediction is accurate according to R-squared and RMSE.
After validating the accuracy of the model, we further compare the reward of two dental bone feeding policies. Figure shows that the experimental group which feed dental bone with RL prediction has higher reward than the control group, which feed dental bone in fixed time intervals.
We designed a unique structure of our dentist bone to make sure it is user-friendly and efficient to use at the same time. The comb-like shape combines with the elliptical cylinder. The complex structure can increase the contact area, improving the efficiency of using dentist balm. The elliptical cylinder structure is made as a grip for the owner to hold dentist balm tightly when the dog is chewing on complex design. The owner will follow the instruction to grab the elliptical cylinder structure when feeding dentist balm, helping the dog's teeth rub more with the dentist balm and increasing the cleaning effect. Furthermore, since dentist balm is a consumable product and eating too many dentist balm might negatively impact the dog's health, we construct a model using reinforcement learning to give the best feeding frequency. The model will calculate the best frequency of feeding and tell the user when they should feed dentist balm. By this model, the dentist balm we produce can successfully applied to all types of dogs.
This year, we collaborated with multiple other teams, discussing project experiments and models, taking surveys, and sharing our experience on social media. In partnership, we collaborated with NTHU Taiwan on a set of shared objectives related to both our projects. We helped NTHU Taiwan in controlling the callus of penis omentia, while NTHU Taiwan helped us measure the OD value of the E. coli and the expression of RFP and GFP. Our science communication helped virtual me up to interacting with future arguments who will hopefully inherit our goals, etc. Science communication helps us share our knowledge with the public, share if we understand our project fully, and make more people know iGym. Due to COVID-19, in-person classes are not allowed in Taiwan these few months. So we've created a science channel and a series of online courses about the knowledge in iGym to reach different age groups in various areas. By concisely introducing biology knowledge, all people can understand the principle of bioclarity, even the child. In iGym, the BioBrick design and mechanism are always described in graph, animation, and words. We believe there is another way for people to grasp the idea and concept of synthetic biology and BioBrick. Thus, we created BioMusic Brick to describe BioBrick through different melodies and atmospheres. The ultimate goal is to make a short melody of each BioBrick element. Users can recombine the order of each element freely and generate a new BioBrick design, also its unique piece. Besides, in our opinion, science is not dull and tedious. We made our design great into souvenirs, proving scientific visions can also be aesthetic and functional at the same time.
Since the efficiency optimization model relies on the detection of OD value to update the parameters of voice in the policy,
we designed a device that can measure OD value easily and quickly in the future.
After the device for measuring OD value is created, we can combine the efficiency optimization model and device into customized products suitable for different branches of dogs.
Furthermore, after the dentist in dogs is complete, the whole project can apply to human beings in the future, which can maintain oral health and benefit the well-being of humans.
We believe that dentists will finally prevent all animals from oral pain shortly.
All animals in this land will have the same right to get simple oral health resources and live a joyful life without interfering with oral disease.